All right, so we spent some time discussing how many significant figures or how many significant digits are in a measurement, and now we're going to start doing some calculations with those measurements. And I think I said something to you or asked you guys, how do you guys decide how many numbers to write down when you off your calculators? Did we have that conversation? Today's the day you learn how many numbers to write down. Okay? To start that process off, though, I want you to do this, because this is going to come up a number of different times. Let's imagine the value $206,020 meters. Yeah, there's a reason why I wrote that out. You'll see why here in a second. I would like you to express that measurement to 1, 2, 3, 4, 5, and 7 significant figures. So there are 6 different answers you're going to write. Each one of them is expressing that value to a different number of significant figures, rounding that value to a different number of significant digits. Ready, set, go. No, that has nothing to do with the number of significant figures. Well, okay, this is the number of significant figures. That just tells me how many places that I moved the decimal point away from the original decimal point. Okay. You'll actually, you're probably your question's going to be answered really soon. All right, hopefully you guys got that as the number you were basing your answers off of. Okay, so to write this, or in other words, round this, let's say this is the value that turned up on your calculator, but for all the rules that we're going to learn here in a couple minutes, we have to write that to one significant figure. How would I go about doing that? Well, this would be that significant figure. Would you guys agree? So what would we write? Well, wouldn't that be it? It's got one significant figure, right?
Are you allowed to just take away numbers like that?
They weren't able to be detected by one of the instruments that was involved in coming up with that result. Not me pulling the hair off of somebody's head. I can't remember who that was. Did I pull the hair off of somebody's head in this class? What was that?
That's like 6,000.
Did I pull the hair off of somebody's head in this class? Okay. Anybody know how much they weigh? Preferably a girl. What do you got? Okay, 230. So I come back here, ready to go, steps on the scale, weighs 230. the rules that we're going to learn here in a little bit, we may find out after a bunch of calculations that this is our result, but because of some ideas that, again, we're going to present, it's only valid to one significant figure. How would we write this to two significant figures? Well, that would be there. Do you guys agree? However, what's that going to cause us to do? It's going to cause us to round it up. So our answer would be 2.1. Sorry about that. You can write it that way. Yes. Oh no, I haven't gone there yet. I was waiting for somebody to mention it. So, Freddie just mentioned it. This we could write as 2 times 10 to the 5th. Everyone's comfortable with that, I think, right? Some of you may have done that. This one could be written as 2.1 times 10 to the 5th. Okay. How about the 3 significant figures, which would be here, right? So, 206,000 or 2.06 times 10 to the 5th. Four significant figures would be to there.
206,100.
Well, we have a dilemma here. That 2 is not going to cause us to round this up to a 1. Go ahead, Megan. That would be the best way to do it. So 2.06 times 10 to the 5th. That would be the best way to do it. Yes? Yes. Yes. You could put the bar above that 0 and have 2 other zeros here. Right. Yes.
So do you remove the, I mean, when the exponent is negative, is that when you move it right?
Yes. Well, yeah. All right. 5 significant figures,
You just write the
which would
number.
be to here. So we're just going to write the number. Interestingly, usually people say, Mr. Lehman, you forgot 6. No, I didn't forget 6. I just went right to 7 just to see what you guys would do. And to get 7 out of this, what would I do?
Write it and then put a decimal point
And there we go. Okay, easy enough. Now, how do we know how many significant figures to write it to? That's the next step. Did anyone get all, were there 6 of those right? I'm going to guess not. Did you? Nicely done. You did too. All right. All right, next. Significant figures and calculations. We're going to go back to a little concept that we looked at earlier this year. You may remember me asking you when we were learning how to estimate when we were measuring. I held up this meter stick and showed the side that had no graduations. I asked you to tell me where my fingers were relative to the edge of the meter stick, right? So if this is 0 and this is 1, and I put my fingers here, and I would like to take a stab as to what part of the meter this appears to be. Go ahead.
0.3.
0.3. And what did it end up having to be? 0.3, dead on. Okay, so you guys are good at this, right? Here's why this matters. Let's say we're going to measure the perimeter of the room. How would one go about measuring the perimeter of the room? Anyone can shout this out.
First go around.
With any instrument, how do you measure the perimeter? What information do you need?
The length of
The length of all the sides, you add them all up, right? Okay, so let's say I measured the depth of the room on both sides with this instrument. Okay, what is this again? Meter stick, okay? So, what's the graduations here? None, right. So, what is the precision level that I can measure using this instrument? To what precision level?
to 1 meter.
Relative to 1 meter.
A tenth.
A tenth, 0.1, right? That's the best I can do. We just did that, right? The best I can do. So let's say I measured that length, and I got 15.3 meters, and I measured that length. Theoretically, I should get 15.3 meters. So far, so good? All right. Then, I'm going to measure the width of the room, both walls, using this instrument, which has all kinds of graduations on it. So what's the precision level of this instrument? Anybody up here can take a stab if you want. To what decimal place? First answer's wrong. Go one more. Go ahead.
1,000th place.
Like I said, first answer's wrong, because that's what each of the little lines represents. We can always estimate in between the lines. Therefore, what's that? 10,000th place. So, this instrument is precise to the 10,000ths of a meter. Okay, anyway. So we measure this one, it turns out to be 11.4728 meters. And then we measure the one back there, it turns out to be 11.47, they messed up a little bit, 31 meters. They're off by a few thousandths of a meter, yeah. They did pretty well, would you say? What's the perimeter? Go ahead. See anybody with calculators out? That's awesome. Wait till tomorrow. We'll be doing amazing things without a calculator. All right, anybody have a value they feel pretty confident in? Okay, we'll go with Paul. 53.5. Really? What'd you get?
53.6 meters.
6. Anybody have anything different than any of those? What'd you get, Fredo? 5. 4. I didn't hear the rest of it. 5.9. Anyone get that one? A lot of you did? Okay. Now, that's what your addition told you, right? Or you got something different?
54 meters.
50 who?
54.
54. Okay. So we got a bunch of different things. All right. Well, let's look at this. What is the precision level of this instrument once again? 10th place. How did I get that number? How was that number arrived at? It was estimated. Do we know that number for sure? Not for sure. We can make a pretty good guess, but we don't know that number. Do we know this number for sure? No. Do we know this number for sure? Oh, absolutely. And beyond. What about this one? Definitely. And beyond. Right? The point I'm trying to make is, how can I state my result? Anything beyond my estimates here. Does that make any sense? I don't even know these for sure, yet I'm going to say, oh, it's this. Well, really, this number we already know is fairly estimated, wouldn't you agree? So I can't say anything beyond that. So, we would only be able to state our answer to some form of that. Turns out we would keep it the same, round down, because that's already 4. So there would be the best answer because of that whole concept. Which brings us to this. There are a number of rules that you're going to learn here shortly that tell you where your answers are valid to, okay, whether you're able to write those down to with any sort of validity. There's a rule for addition and subtraction. You showed kind of the rule for addition. There's a rule for multiplication and division, which are the ones we're going to be spending most of the time on this year. There's also a rule for logarithms, but we won't be into logarithms until like March or so. So I'll hold that rule off until we actually start using those. Anyway, let me just tell you what the rules are. I'll throw some examples up and we'll try and practice. Sound like a plan? Here we go. First rule. Let's do multiplication and division first. No. We already got addition and subtraction on. Let's do addition and subtraction. So, for addition and subtraction, the answer is rounded to, I'll repeat this like 15 times. Well, for addition and subtraction, the answer is rounded to the same level of precision as the measurement for addition and subtraction, the answer is rounded to the same level of precision as the measurement with, sorry about that, as the least precise measurement. Sorry about that. So, for addition and subtraction, the answer is rounded to the same level of precision as the least precise measurement. And we need the whole thing. Now, we just demonstrated that here. Would you agree? Least precise measurement to the 10th place. Our answer is only valid to the 10th place. Hunky dory? Okay. I'll give some more examples here in a little bit. I want to get the multiplication and division rule done so that it's all on video and we can be done with that. For multiplication and division. Now, I do want to say this. Both rules by themselves are incredibly easy. The problem that we run into once in a while is you guys forget which rule goes with which operations. You can imagine that, right? So here we go. For multiplication and division, the answer is rounded to the same number of significant figures. For multiplication and division, the answer is rounded to the same number of significant digits as the measurement with the fewest significant digits. Yeah, I'll do it again. For multiplication and division, the answer is rounded to the same number of significant digits as the measurement with the fewest significant digits. So, for example, ooh, I don't like that example. I should do a different example. But I'm not going to. Let's try this. You might have to get out your handy dandy calculators for that one. You guys part of the handy dandy era? That would be a no. No one knows what I'm talking about when I say that. That's a good one. It's a really bad show for kids. What was that called? Something about a blue ball.
Blue's Clues?
Yeah,
Oh, I
there you
love
go.
those.
So you guys were of the handy dandy era?
Oh, yes, yeah.
Okay.
Handy dandy?
Handy dandy.
Oh, yeah, I remember that.
I think I hit 3 sides of the fraction. All right, anyone want to offer up? Well, you know what, let's do this. Just tell me what's on your calculator. Do you have what's on your calculator available? No. Do you have what's on your calculator available?
Yeah, it's 1.433437.5.
And unit, everyone.
Grams per milliliter.
Grams per milliliter. Excellent, excellent, excellent. Okay, now we have, we're looking at the number of significant figures because we're doing division in this case. So how many significant figures in this measurement? 4. And this one has? 2. Therefore, our answer has to be rounded to 2 significant digits, which is right here. Therefore, 1.4 grams per milliliter. Pretty easy rule, would you agree? Both of them, very easy rules. Just don't screw it up. Because then you'll start finding people mix and match the rules a little bit, and that can cause problems. I am going to give you one more multiplication and division example because it's going to introduce another thing. And then I'm going to give you probably 3 or 4 additional addition and subtraction ones because there's a couple other things we need to practice and look at. Let's try this multiplication and division one. Okay. What do you have on your calculator? You don't. What do you have on your calculator?
397.978
Centimeters
square.
squared. Okay. That's what you guys have on your calculators, yes? Hopefully. Yes.
I just have a question.
Yes.
Since you would do it to the significant figures, couldn't you just do 14 times 28?
No, because this was a measurement that had these values available. We were able to actually measure those, okay? So we have to include those.
Okay.
All right, and that's going to bring up another can of worms that somebody else was referring to earlier, so, yes. Well, it's not. So, but let's hold on a second here, okay? So, how many significant digits? 5. 2. Since we're multiplying, we care about how many there are. In this case, this has the fewest number, which is 2. So we have to round this one to 2 significant digits, which is right here. 40 is not the answer. Now, I had to say that because about 6 of you were thinking that, maybe more. Okay? What is the answer?
Is it 400 with a decimal?
Ooh, close. He said, is it 400 with a decimal meaning right there? I hope. But that's incorrect. Because how many significant digits is that?
Oh, it's 3.
That's 3. Go ahead.
390.
Oh, no, because aren't we going to round up? That's a 7.
You have to write it in scientific
Scientific notation, what would we write?
4.0.
That's it. 4.0 times 10 to the second centimeters squared. Okay. That was a little fun. Patience, people. Patience. That's all it requires. All right. A couple of addition and subtraction examples. And I am going to run out of time. We're going to write them down so that when we come in tomorrow, we'll be able to just go. So here they are. I need 5 more